Thank you very much for the introduction. So for those who don't know me yet, I've joined DVB as a head of technology at the very beginning of 2020, which means that I arrived at the same time as the COVID, which is why I've never been attending the BU technical committee yet with this new role. So I'm very happy to be here. Thank you very much for the invitation. So I'm very happy to meet the people from the ABU, but I've been quite involved a lot in the past through my previous roles in the Asian countries, also India, and coming here again after maybe, so India was 6 years last time I've been here, and I've been there many times for projects like links to DVB-I, DVB-H, then DVB-T2 lines, now maybe native IP, but I realize that there is very a struggle actually to have broadcast on mobile devices. So I think that now nearly 15 years ago, so DVB-H was 15 years ago, T2 Lite was 6-8 years ago. Now again, we have that issue of delivering broadcast to mobile phones. And I realized that as long as we have to change the mobile phones, if you need to integrate an antenna, and so on, it's very difficult because now, as always, telecom operators want to sell data, but broadcast kills data actually. So I realize how difficult it is. So I think that my presentation will come, it's very timely because I will focus on DVB native IP, which is the new standard for delivering media to any connected phones and any device actually. So I'll first give as an introduction, we have a shift in focus in DVB, so I just wanted to tackle this as an introduction. Then I also go back in history to just give you the full picture about our solutions because things change a lot those recent years. And then I'll focus on native IP and I will try to keep some time left for DVB-I, which is very important. Actually, these are the two pillars for the new DVB solutions, IP-centric solutions, native IP and DVB-I. So first you may wonder, you've heard, I guess, about those DVB IP-centric solutions. So you may wonder, are we moving away from broadcast actually? Well, the short answer is no, but I guess you want some more explanations. So you remember at the time where the whole industry came at DVB to solve the issue of transport. We needed at that time to replace analog TV with something digital media delivery, and that's why DVB was created, by the way. And that was the really hot topic, service delivery. And the need was to create this reliable and efficient transport network. But time has changed, of course, and there is a clear shift to a new mandate now for DVB, which is help the industry tackle and transition to seamless experience in this really in this fragmented world. So there's a clear shift from delivery to discovery. So today we want the industry to get rid of those silos. And we want to define a common service discovery across any networks. And that's what DVB is, what DVB-I is achieving. Of course, internet services are delivered via different formats again, but there is DVB-, for instance, that we defined for higher interoperability and many other things. But DVB- is one of the mechanisms to deliver internet services. And DVB-I is the mechanism that will allow those services to be merged together with services coming from any network. And that's really the power of DVB-I. It's to retrieve services coming from everywhere. This can be the services coming from satellite, terrestrial, even cable, and in the future, service coming from broadcasts, especially 5G broadcasts. So this is really how we achieve a hybrid delivery, which is made seamless, because this standard is the thing that make the experience on the user side to be harmonized, unified, because those services that will reach your phone or your TV set are the ones that match both your device capabilities and also your preferences. So it's a merge, I would say, in an intelligent manner. And this also can be used to, of course, tackle those migrations to IP, because the experience is made seamless on the end user side. So yes, we are indeed embracing those new broadband technologies, but only in a way that make things easier for the industry. I mean, to achieve success in those transitions. And there's no reason actually to get rid of broadcast unique specificities, as you know, I guess here. So we are only building the tools that get the best out of both worlds. So now let's go back in history just a bit to explain, to give you an idea of those new solutions that started a few years ago, to give you the full picture. So you know that most TV platforms used to rely on this well-known MPEG-2 formats, but those were designed for one-way broadcast networks. And at that time, the flagship solutions were DVB-S2, TT2, and so on. The service discovery at that time was just something people were less aware of, but it was actually very essential, because this is what enabled a nice user experience. This is what enabled the TV experience, of course. And in parallel, we had, of course, the mobile device industry that developed a completely new approach, new system, besides the use of some common codecs. So they are using adaptive bitrate technologies, known as ABR, the DRM for content protection, and so on. However, on the user side, the experience is a bit puzzling, because there's no real way to, it's not TV, it's streaming, but the user can be sometimes really, puzzled by so many services, the users are lost. So those two different solutions have been coexisting now quite for long, and operators need to have on one side a broadcast headend to target the legacy devices, and on the other hand, the broadband headend, of course, to tackle, I mean, to address the new connected devices. So DVB started a few years ago to bring a pinch of broadcast in this broadband world. So we have progressively profiled the codecs to offer some more interoperability across networks, broadcast and broadband networks. Next, DVB-, so it's building an MPEG- and it's bringing some more interoperability. It brings low latency also to reduce the discrepancy between broadcast and broadband tapping times. Next, we introduced DVB-NIP, which is a way to enrich the broadband networks with the scalability and the reliability of broadcast. So you can achieve really cost optimization for the delivery of high demand content, of course, because your networks will no longer depend, I mean, your IP networks will no longer depend on the number of viewers when you are doing this this MABR. So MABR initially was defined for IP networks. And DVB-I, so DVB-I is actually what brings the TV experience to this streaming world. It's not only for IP devices actually, but for any, not only for, IP services, but for only service coming from anywhere. So especially those coming through regular DVB-S2, TT2, for instance. And those services will be merged in a harmonized service list. But still, you see that we have those two different systems, so two different technologies which still coexist in their own silos, and there are still two types of broadband and broadcast headends for the operator. So we are still all struggling. So this is just decided to show you that also DVB-I is the one that bridges broadcast and broadband on the end user side. This is on the bottom part. And now we see there's still a wall on the delivery side. So there's still a need for something that could work using today's internet formats, so those which are tailored for IP devices, and offer them, deliver them in a high quality, so with a broadcast-like experience to those users. And we want them to don't have to care about whether they receive it from IP or from broadcast. And that's exactly what we are doing with native IP. So you see that native IP is bridging the two worlds, but on the delivery side, so on the transport layer. So to do so, so we have extended the codecs profiling to have a much higher interoperability for the benefit of all, I mean, manufacturers, operators, and so on. Native IP is using DVB- for the packaging format. And next, a very essential block is DVB-NIP, because of course, if you want to broadcast, you need something with a flat bandwidth. So DVB-NIP is the key here. And then you have two different possibilities. So for the long term, native IP will use DVB-GAC, which is purely native IP. So this will work over T2 and S2X. And this is the real, I would say, native IP solution. However, for the transition period and for a quicker launch, we have a second mode, which is the backward compatible mode, which is using DVB-MPE, which is then compatible with MPEG-2 TS formats. This is you can use it with S2 also in addition to S2X, and of course T2 also. So this is the MPEG-TS based, I would say, native IP solution for early deployments. So you see that now we have a really unified landscape where you have regular broadcast, you have native IP over broadcast in two different modes, and you have broadband, which can be either purely unicast, as it used to be the case in the past, or multicast for higher scalability, reliability above all. So this is the full picture. Now I hope you understand a bit better what are the solutions from DVB that we have recently published. And now I'd like to focus on native IP. So on the delivery side, what you can do with that and how you can implement. So it opens up new business models, and it also brings TV to mobile devices where IP network would fail. So this is one of the use case which makes sense, I think, in some countries of this area in Asia and India. So by simply leveraging the existing broadband and broadcast infrastructure, you will be able to bring TV to mobile devices where you don't have any internet. So when you have a broadband headend, which is the case now for more and more broadcasters, because they have to keep relevant, so they have, in addition, they have a headend for OTT services. So with this regular broadband headend, so first I just show what is done in the case of regular, traditional streaming. You have so the content is encoded, sent over the network, perhaps using DVB-I to improve the user experience. It's not mandatory, but this is something you can add on. However, this uses unicast, so it means that if you have 1 million users on a service, you will have 1 million streams, and the cost increase exponentially. So this is regular streaming, and in many places you cannot afford to to scale your network for enough users. So this is where broadband infrastructure is sometimes struggling during peak hours, or in some countries or some areas where the broadband network is less strong. So how would you do in some place to receive native IP? So what's different? Well, you just can reuse the broadcast transmissions, so your satellite or terrestrial existing transmission. However, you will insert in the broadband headend, you will have to insert only the packaging and the server that will convert multicast into unicast into multicast, and the IP encapsulation that can be either MPE or GAC. And this only need to be added. Then you have the regular modulation, it can be T2 or S2 or S2X. Regular broadcast transmission. And on the receiving side, you will have a gateway that will implement, so nearly the same, the inverse actions. So you will demodulate, of course. And then you will have this MPE or GAC de-encapsulation. And finally, you will have the MABR client, which is, on the contrary, it will convert back the streams from multicast to unicast, which means that the services that you will stream will be exactly the same as the ones that you will have using a regular internet streaming. So this is what is very strong, is that any current and any of the today's receivers can be natively compliant because you just use a Wi-Fi connection. So you have an optional return pass. So depending on the use cases, there are plenty of different use cases. But when you are in a connected, even in low connectivity environments, you can have a return pass. In this case, you can have a content protection of sometimes, which is in some cases very useful also if some private broadcasters want to use the solution. And for the other use cases, for targeted advertising, or for, there are many use cases where it's needed, but for the basic live TV transmission or push TV, it's not needed. And for the future, there is also potentially a complementarity with 5G broadcast, for instance, because while you're on the go, the mobile devices are not connected anymore or are not covered anymore by a gateway. In that case, they may be served in the future by a 5G broadcast connection, for instance, or regular 5G or so. In that case, it's not multicast anymore. It's just regular streaming over even 4G transmissions. And by the way, there is also a seamless indoor-outdoor coverage thanks to DVB-I, because if you have the DVB-I client on the phone, DVB-I will automatically retrieve the services. So when the user is covered by a gateway, a native IP gateway, then it will get the streams from there. And when you are on the go, when you're outside, and if you receive the same stream through unicast over an LTE connection, in that case, it will switch automatically to this. So that's also the combination of native IP with DVB-I, which make it very, very powerful. So this is to show what's needed to achieve a native IP transmission, which is quite it's a very low-hanging fruit, actually. So in terms of business and models, there are different ways it can be used, and it has started to, I mean, the business which is leading this rollout is, native IP rollout is more in the short term B2B use cases. So in public places, so native IP hotspots. So in that case, you have a professional receiver streaming to the regular Wi-Fi infrastructure in a premise, or it can be some sports channels in a bar. This can be some premium channels in hotels, because you know hotels are struggling in some areas when they have to offer a reliable internet service. When everyone is back at the hotel at the same time in peak hour, streaming doesn't work anymore, because either you pay a lot of money to get a high bandwidth, or you have to cope with that issue. So with native IP, you can put your premium channels, for instance, on over broadcast, and then it does not take anymore your broadband network. And this can be applied in many different ways. There are some e-learning programs which are being investigated. You can implement that in some malls. There are some maritime deployments being discussed. Actually, any public venues, any area where there's any waiting area, actually, or any place where you have some captive audience also can be very interesting, because, for instance, in a bus for some very long journeys, if you offer this service, you can offer also advertisements that go with it. So you boost the attractiveness of your bus company, for instance, while adding some, you gain money also from the advertisers and so on. There are many different use cases where this can be used. There's another one, yeah, with hotspots in rural villages. Of course, you can bring higher education level thanks to the TV, which is made available to mobile devices. So overall, what needs to be the takeaway is that live TV can be enabled in the poor connectivity areas, or even in TV-less environments. And this is, I think, in some countries, very crucial. And for the longer term, we can say that it enables that truly converged media delivery ecosystem, because when the native IP streams will be all over the air on satellite and terrestrial networks, of course, you will have only that. Those streams will serve both the TV sets and the connected devices, because that's the format, I mean, for the future. So in that case, you will have a consumer gateway, which will be the homes that will serve the main screen, so through the regular HDMI connection, and the IP devices of the phones. So the gateway will stream the DVB- so regular OTT to those phones. So it will be unifying the platforms on the head-end side. It will allow broadcasters to have higher reach in homes, because they no longer limit themselves to the main screen. And so you enable some use cases like multi-screen, multi-room, and so on. So as a summary on native IP.
We conclude, running out of time. So,
yeah. So I summarize on native IP, saying that all will gain thanks to native IP, because broadcasters can launch OTT services. And even in low connectivity areas, and they have higher reach in the homes. Satellite providers also are very much interested in that solution, because they can sell additional bandwidth for the OTT use case. So they have a role to play in that area. And they stay so relevant in the future when DTH will be able to use the same formats as the one used widely. OTT providers can scale down their infrastructures. If they use broadcast for the most popular channels, for instance, they will reduce the cost. And they will also extend their market reach, because they will go beyond the well-connected areas. And there are also other advantages for all, which is that the content personalization is made easier because it's much easier on IP streams compared to MPTS-based streams. So you can personalize the content, add insertion, and so on. Live and push TV is served with broadcast quality anywhere, and is natively compliant with the existing devices, and this is a very key advantage also. And it contributes to a more sustainable world, because the broadcast nature, of course, is more sustainable. So there is less power consumption due to the one-to-all instead of unicast. So I will not maybe detail now DVB-I. So DVB-I, there are a lot of presentations on the DVB website, some webinars, some other conferences. And I'm happy also to answer any question related to either native IP or DVB-I, of course. Thank you very much.
Thank you, Emily, for addressing the mobility in broadcasting, on how DVB-T bridges the broadcast and broadband on the user side, on the transport layer, on the converged media delivery ecosystem, on the potential complementarity with 5G, and with the business models.
Yeah, Nigel Fry from BBC World Service. A question to Emily with regard to the DVB over or DVB IP format. I was just wondering if you'd give us an idea of the overhead that may be associated with that stream compared with perhaps a normal satellite DVB satellite stream.
So do you mean the overhead for the DVB native IP streams in that case? I guess.
Yes.
Because DVB-I is a discovery mechanism, so there's no overhead except metadata, which is very not significant at all. So native IP, so using regular, so the backward compatible solution based on MPE, so with regular MPEG-2TS, well, there's no overhead, it's the same encapsulation format. So for one, if you have only one representation of the stream, because so ABR is using multiple representations usually, but if you, in the case you would use only one representation, there would be no overhead or nothing significant because it's still using MPEG-2TS. However, if you would use the GAC-based one, on another hand, on the contrary, you would have much less, well, I think it's between 20 and 30% less bandwidth. Well, those figures need to be confirmed, but the GAC is much less bitrate demanding, so you would improve the efficiency using GAC. However, I'm speaking with only one representation, so maybe your question is that if you need so real ABR, so if you need to send with multiple representations, in this case, it just depends on how many resolutions you want to transmit, of course. So I'm not sure it's answering your question.
It's a good point to start. Thank you.
Thank you.
One more question. We have any? Yeah, Musanil.
This native IP thing, is it implemented somewhere or is in the process of implementation?
Native IP, right?
Yeah.
Yeah.
Native IP.
So native IP, so it has been published in February this year. So today we are currently in the what we call the V&V process, which means that we are verifying specs, and to do so we are implementing for test. It means that all the stakeholders that were involved in the standardization are now involved in creating the tools to implement. So open source software, reference streams. So it's a kind of early implementation. So we have so members who joined the efforts to create a demonstration headends. So we have tests for commercial deployments. Of course, this will take longer. However, so that was about the standard itself, but we had some deployments before the standards, because as you know, the standard came quite late. And before we had some, so you maybe have heard about the AstroCine, which is a deployment in Malaysia. So it's not DVB native IP, but it's exactly the ID. I mean, they are using the same bits of the DVB blocks, where with native IP we have finalized the work, but there are some early implementations before the standard was ready, and there were some technical issues because of the lack of the standard. But you see, there are some markets who started even before the standard because there is a real need for that. So the need here was, I mean, the use case was to feed hotels, you know, because bandwidths are very small, and then they wanted to have a more premium quality. So they were using OTT over satellite, using the existing DVB tools, but lacking some interoperability. So that's why it was very difficult for them to deploy. But there is something, and few ones are coming. Now the standard is ready.